All right, the next couple weeks, we are gonna spend strictly on triangles. So you can see it says triangles, triangles, and more triangles. Today, we're gonna look at how to classify triangles and also some rules that go with interior and exterior angles. All right, so hopefully everything we do today is gonna be review. So let's talk about classifying triangles. When you are asked to classify triangles, all right, you should always give one side and one angle description, okay? To classify by the sides, there are three possible choices. We have equilateral triangles, isosceles triangles, and scalene triangles. Equilateral triangles, that's when all the sides are congruent. So it looks something like this, and you will see it labeled with the tick marks to show all three sides are congruent. An isosceles triangle has at least two sides congruent. Now it says at least two sides. All right, so we'll draw it first, mark our two congruent sides. But actually, an equilateral triangle is a special isosceles triangle. So if it has all three sides congruent, right, it also is isosceles, but we use the better word, the more specific word, equilateral, when all three sides are the same. All right, so isosceles will be when there's just two. All right, equilateral will be when all three. But please just recognize this specific definition is that there's at least two sides congruent. Scalene, none of the sides are congruent. So you won't see any tick marks at all to show anything congruent. All right, those are the three classifying words for sides. For angles, we've got four words. We've got equiangular triangles, acute triangles, obtuse triangles, and right triangles. All right, equiangular, that's when all the angles are congruent. So it will be marked with arcs. We'll have the same arc in each of the angles. Now, equilateral and equiangular always go together. So if you know that it's equiangular, then you know it's equilateral and vice versa. Now, we're going to review in a minute that the three angles, interior angles of a triangle always add up to be 180. So if I take 180 and divide it evenly by 3, we always mathematically get 60, 60, and 60. So an equiangular and equilateral triangles always have 360-degree angles. Now, notice that those three measures are all acute. So an equiangular is a special kind of acute triangle. But again, if we know they're all 60, we use the more specific word equiangular to describe it. But if the three angles are not all 60, but maybe they're 60, 50, and 70, and again, all three of them are less than 90 degrees, then that would be an acute triangle. If one of the angles in the triangle is greater than 90 degrees, and there can only be one, right? It would be called an obtuse triangle. And then, of course, if one of the angles in your triangle is a right angle, 90-degree angle, then that's a right triangle. All right. So again, when you're asked to classify, you're going to give one of the three side words to describe it and one of the four angle words to describe it. Now, isosceles triangles and right triangles have special names for their parts. Isosceles triangles, we know that there are going to be two sides congruent. These sides are called legs. So the two legs of your isosceles triangle are always the congruent ones. The third side is called the base. Now, across from the base, this one angle up here, that's known as the vertex angle. The two angles across from your legs are called base angles. And notice the way that I marked them, because if you have two congruent sides in a triangle, you will always have two congruent angles. So I did mark these with the same arc to show they will be congruent. We will spend tomorrow talking more specifically about isosceles and equilateral triangles. Right triangles also have special names. All right, we're definitely going to have the box to show the right angle. The two sides that make the right angle are also called legs, just like in an isosceles triangle. But the third side that's across from the right angle is called the hypotenuse. And in a right triangle, that is always the longest side. Okay. There are no special names for the two other angles. Those are just acute angles. They'll always be less than 90 degrees. We spent an entire chapter on right triangles a little bit later in the class. All right. So that's a bunch of vocabulary. Let's look at some angles. All right, we have exterior and we have interior angles. So obviously in a triangle, all right, and I mark these with eyes for interior. We've got three of them always. If we extend the side, just one of the sides going out, our exterior angles will be created on the outside of our triangle. Hopefully what you notice is that your exterior angle always forms a linear pair with the interior angle. All right, so over here, I'm going to extend it both ways. All right, so again, here were my three interior angles. So the exterior ones are only the ones that form a linear pair. So at each interior angle, there's actually two possible exterior angles. All right, notice they're vertical to each other. So the angle that's vertical to your interior angle is not called anything. It's not exterior. All right, it's just the ones that form a linear pair. Okay. So there are some rules that go with our interior and exterior angles. The first one has to do with our interior angles. It's called the triangle sum theorem. And it reminds us that the sum of the measures of our interior angles is 180 degrees. So any triangle, the measure of angle A, the measure of angle B, and the measure of angle C will add up to equal 180. Right? You'll be solving lots of problems using that rule today. Exterior angle theorem. Actually, let me back up to the triangle sum theorem. Let's do a little problem here. Let's put X in angle A, that will be our missing. Let's make this one 62 degrees and this one 57 degrees. All right, so given a triangle where you know two of the three angles, you would simply add the 62 and the 57, and we get 119. And then we would subtract that from 180 to get the remaining angle. And we get 61. So we would say X equals 61 degrees. All right, that's a very simple problem. If you've got algebraic expressions in your three angles, then you would add the three expressions together and set them equal to 180 and then solve for X that way. All right, back to the exterior angle. The exterior angle theorem says The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. All right, so here's a picture with an exterior angle labeled. We know it makes a linear pair with the interior angle, with one of the interior angles. The other two, these are the remote interior. If you think about the word remote, like a remote control on a television, okay, it's away from the TV. All right, so one of the interiors is a linear pair with your exterior. The other two are remote interiors. So again, the rule says an exterior angle equals the sum of the two remote interiors. So when I look at this picture, I know that y, because that's my exterior angle, is going to equal the sum of 62 plus 84. That's how I would set my equation up. And then we solve it and we get 146 degrees. All right, in this picture, again, exterior angle is the 138. So the 138 equals the sum of the two remote interiors, so z plus 32. And then this time I would just subtract 32. So z is going to end up equaling 106 degrees. Okay. Now, there are ways where you could use the linear pair rule, you know, these two equal 180 to figure out this interior angle and then use the interior angle rule. No harm in doing it that way. There's just two steps to get there. Where using this exterior angle rule, there's only one step. Okay. And then lastly, there's this corollary to the triangle sum theorem. Now, this is a new word, corollary. And this just means it's a rule that easily follows. Rule that easily follows. All right, so up above, the triangle sum theorem said the three angles add to be 180. So the corollary to that is if you have a right triangle, which means one of the angles must be 90, then the rule says the acute angles of a right triangle will always be complementary. And I hope that makes sense, because if you take the 90 away from 180, what has to be left is still 90. So that means angle A and the measure of angle B have to add up to be 90 also. All right, so just something to think about. You may certainly use the three angles add to 180 rule always, but this is just something special to right triangles. All right, so those are the rules you're going to be using today. You should be ready to practice.